All right, so moving on, the context remains the same, the interconnection of AI, ML, IoT, now with a new perspective from insurance to supply chain optimization. To present, we have Rajesh Savio, Director Product Management from ICA Software Solutions. Rajesh, request you to please upload your presentation.
Thank you so much, Abhilasha and 1.21 GWS for having me here. My name is Rajesh. I'll come into the introduction, and thank you so much, Deepak, on the SAP insurance use case. It was really an eye opener. So today I'm going to be talking about AI-enabled RPA through AMRs. So the focus is primarily going to be a lot on AMRs, which are autonomous mobile robots, and it's for global supply chains. I work for ECA Software Solutions as a Director for Product Management. Quick intro about myself. I'm from Bangalore. I've about 16 plus years in SaaS transformation in supply chain, fintech, and procure tech to be precise. I've done a lot of implementations, delivery, and I'm also building world-class SaaS S2P products for ECA solution right now. So I'd like to call myself a perpetual learner, technology freak, an agilist. I have a lot of enthusiasm for getting certifications done. You can also track me on YouTube. I speak a lot on social awareness and also about latest technological innovations. I'm a dad. I'm a son. I like to keep fit, so I run a little bit. I'm also a husband. So that's a little bit about me. So quickly jumping into what I'm going to be talking about today. I'm going to be keeping it very simple. I'm not going to be getting into the processes or how things are going to be done. Recently, I had an opportunity to study with Sheffield University on AMRs, and this is one of an extract of a couple of things that I've learned, a couple of things that is going on in the world, and a couple of things that I am part of in my professional or current professional career, where I'm designing S2P suites, warehouse management suites, which can talk to each other. And then you have this mobile robot concept, which is there, which is more of a hardware thing that you can actually see. So we saw a lot about RPA in terms of software. I am also going to be covering a lot of software related aspects, which is coming into the AI part, like path planning, so on and so forth. But what exactly is an AMR and how is it journeyed across some time? I'll also touch a little bit about that and probably also talk about the market overview. So robotics has always been there. It's been there from a long time. People have been building robots, and even our old school, remote cars and remote aeroplanes are all robotics in a way. But when it comes to global supply chain, robotics was kind of adhered to or kind of welcomed very late. E-commerce was the first to adopt it, but in supply chain, when you have a regular buyer, a regular supplier, and then you have warehouse management, it was always paper related, phones related. It was men related, especially I'm used to seeing warehouses with a lot of men, carrying goods here and there, but not really an automated warehouse. And so that situation, that scenario of a typical warehouse or a go down or an inventory, a storage place has gradually changed, and now it is completely automated. So in the past 2 years, because of COVID, we saw a lot of transitions. We saw global supply chains coming to standstill, the Suez crisis followed by the container crisis and the pandemic itself. All these were, eye openers for, corporates or enterprises who deal with manufacturing and then movement of stuff, receiving them and then storing them. So without people, it was very difficult. And right now, there is a significant amount of change, significant amount of welcomeness, which I've seen in the market towards AMRs. So AMRs come in different shapes and sizes, and you need a lot of infrastructure. It's not just the robot which is there, as you see here, the ones which are flying and the ones which are on the ground. It's not just that piece. There's a lot of programming. There's a lot of path planning system. There's a lot of other things which get into it. Having said that, how's the market for AMR automation? So the global market, as we speak, in 2021 stands at about 43.8 billion, and the CAGR growth that's speculated, that's forecasted, is almost double, and it is close to 70.6 billion US dollars by 2028, and that's a huge a tremendous growth peak that I see for a technology which is so new and which is so naive, also has a lot of interdependent technology which is going in. So for me, I'm not going to be talking about the processes. I'm not going to be talking about the project planning aspect of it. You can just look at this as a case study, what I studied and what I presented to Sheffield University to get the certification done. The key slide is going to be the last but one slide. I'll come to that. That's where I wanted to envisage and show the entire supply chain with AMR and AI and different technologies which can automate it. So you might have seen, you might have read that Walmart, after the Suez crisis, woke up, and then the AMR inventory space for Walmart has announced huge investments, including companies like ABB, Fanuc, Shunk, and all these companies buying. They all manufacture AMRs in different forms and ways, which we'll talk about in the coming slides. DHL, which is again a transportation and a logistics company, has invested heavily in locus robotics. So there are lots of robotics companies out there specializing in different types and different varieties of AMRs. And they look forward to also growing that to about 2000 by 2022. Amazon, as we speak, I've had a chance to work with Amazon during the career, and has gotten a lot into AMR related automation or RPA for their warehouses. And classically speaking, I just off the fly, I realized that Nike, I was reading about Nike the other day, and Nike's warehouses are now completely automated. That means to say that every order that you place on Nike.com or sneakers.com, which is their subsidiary, you get all their brands, that is Nike, Air Jordan, Converse, and even the Metaverse NFT that they procure right now. You can get all these things completely humanless. So there's not going to be a human who's going to be touching it. From the order placement, from the receiving, from the dispatch, it's going to be completely automated, especially if you're buying it on their website, which is great. So having said that, this is just brief about the AMR automation market, which is out there. Quickly, I just wanted to also touch base on the different types of AMRs which are available, broadly classified. I have classified it into 4 buckets, but then there's no limit to the way you can actually classify AMRs. They come with nuts and bolts. They sometimes fly, they sometimes move, they sometimes crawl. They sometimes emerge out of pits in warehouses wherein the warehouse needs you, or there's a need or a requirement to travel across racks or come down across racks. So there's a lot of use cases, a lot of different variations or permutation and combinations of these. Basically, broadly, you can classify these things into four groups. Goods to person picking robots. That could be your everyday robots, the ones that you see on LinkedIn, ones that you see on videos that just come to you, pick up something, a binary motion, and then go back and keep it over there. Keeping might not be part of the exercise, but then you can also program it. But the warehouse or the AMR that are used in supply chain, these are primarily, dependent on their acrobatic movements or their limb movements. Some have limbs and some don't. And the other one is the aerial and manned vehicles. So each of these AMRs come with their own limitations, positives, and that it would be a seminar or a workshop for a different time and day, which will have more, technical aspects to it. But from a very high level, some of the new varieties which are coming in can also run, can also move in multi-diagonal directions, not only in linear directions, and so on and so forth. Self-driving forklifts I've seen. I've worked for a very huge pharmaceutical company, manufacturing setup in Bangalore and also across Southeast Asia. And they manufacture a lot of pharmaceutical stuff. So their consignment or their inventory has to be in certain boxes, which has to be eco-friendly. It has to be away from pesticides. It should be anti-pesticidal in nature. It should be antifungal in nature. So when the consignment comes in, they have forklifts or automated forklifts which can lift it and lift the consignment, which are herbs, could be packages or anything, and place it into these complacent boxes, which can then be put into conveyor-led automated conveyors. So everything, we'll look at the final picture, but everything can be automated. Everything with limbs or which moves can be automated. The data from that can be extracted and sent back to processing systems. Autonomous inventory robots are those which can climb. onto racks, which can go into depths, which are also used as exploratory robots, which can get into the nook and cranny of places, use the area which is available optimally, so on and so forth. Unmanned vehicles, aerial vehicles that we've been reading about very often and being tested around. Certain levels of tests have been proven for B2C, but for B2B, it's still an unexplored or a very less explored terrain, the unmanned aerial vehicles, when compared to the entire AMR range. This particular unmanned aerial vehicles is very less explored and less utilized even for supply chain because of the distance issues, because of unmanned robberies in between, the safety of the people around, those sort of things. And it is still it has crossed beta testing, and it is now into the next levels of testing across various enterprises and companies that are manufacturing this. The basic components, very simple. It cannot be classified, cannot be put in a box. But these components are ultimately the ones which are going to be talking to your external systems, which are going to be assimilating the AI programs and doing a lot of stuff. So hardware is used to typically have your motors, sensors. You have a lot of AMR kits which you can do it, DIY kind of kits which you can buy and which you can do. I'm a huge fan of it, and it works really fine if you have kids around. My suggestion is to you should try those DIY robots, and which are actually very similar in look and feel, and do a lot of other very interesting things as well. So when we come to software part, this just one line over there, but the software part is the critical part of it, without which it's just a action figure. So path planning for me has been a very critical discovery or learning in the past few years, which is an algorithm, which is an AI-based algorithm itself, and there are so many different types of path plannings. So I'll touch upon the path planning aspect in the next couple of slides. While we have the path planning algorithms running, the data which is assimilated, the data which is extracted from all of this robots could be just measuring the entire layout of space that you have in your inventory. They are used for they have sensors, and they can be used for that as well. From that information to the intake of stock, to the to the dispatch of materials, to the relational databases that are working across different SaaS entities. So I come from a SaaS background. So the systems that I develop do a handshake with the mechanical robots. Whereas the bots, which we spoke about all this while in the past sessions, are all software related, but then the handshake between the mechanical and the software is very evident in such things. That's why I urge you to buy a DIY AMR or robot and fix it and start playing with it. And you can see that how the software, and you can actually connect these to open code softwares, and you can, if you know the language, that is, most of it comes in Python. I'll talk about that later. You can go ahead and customize it with the software. You can do a lot of other things as well. And when you collect all these things, this data becomes paramount. And this data has to be transcended into various SaaS infrastructures, like my own company's infrastructure, which is a car platform, which is dealing with SCM automation through API management. And the API management is a key factor which I've kind of started working on these days. And APIs also, the way your APIs are mapped, and if you get in an iPaaS solution in between as a middleware, it's going to work out great. But even then, if you don't have it, and if you only have, you're using hardcore API programming methodologies, still there is a lot of unmanned or unexplored territory from an AI and a robotics AML API management. So that space, robotics, AI and API management, I also feel that it is a little more underexplored, and we should be exploring it more. Once you get all this information from a standalone software perspective, what all can you do? That again is what I think we discussed. Once the data is there, there are other robots, software robots, bots which are programmed and which can do the mundane activity of dispatching it and getting OKs done, and OK to pay inventory, ERP to inventory, transaction of data, and the data between the actual robots itself. Quickly, let's talk about path planning. So when we're talking about AMRs, the way they are constructed, the way they are required to move from point A to point B, is what a path planning software is. And it's an algorithm by itself, and there are various different types of algorithms out there, various different series of algorithms out there, and choosing the appropriate path for planning an algorithm to ensure safety and various ecology, sustainability, and various other nuances which only the use case will bring in. I could be transporting fragile things. I could be transporting huge machinery components which weigh a ton, and I could be transporting flowers which are very fragile and uh, could be prone to a lot of misuse. So path planning depends. Path planning is the critical and most important aspect that will make your robot, your AMR function in a particular way. And the AMRs also need to come developed, and it needs to have that certain nuanced uh, fitment with the software. So you cannot have a software programmed for the aerial unmanned vehicles running a the door-to-door kind of a robot. So that's not going to work. So that's very important. So path plannings, these are some of the common algorithms that I've come across. Some of the very famously used. So we have the A series. I'll just quickly explain what these things are, because this is the AI part that will ultimately make your AMR function in the way that you ideally want it to be. And there's a lot of research which is going on right now with respect to a lot of other robotics and sensory mechanisms that the robots are developing, including touch, which we'll talk about. So A series is a series of algorithms which guides the AMR to the most promising state. So this is just one line. I'm talking at a very high level, but when we dig down into it, what we're actually looking at is moving from one point to another point. What happens in between, what happens about obstacles, all of these things are not really considered in this. This is a little primitive, and it's only talking about huge places where you can really commute. D-Star series, again, collision free. This comes with a sensor. So if the AMRs are equipped with sensors, you have various different types of sensors. And if the path amidst it has an obstacle, or if the obstacle, we'll talk about that in Firefly series, wherein the obstacles are required in that algorithm. Quite contrasting and very interesting to study these algorithms and actually see them work. So for D-Star, collision-free path amidst moving obstacles. If there are moving obstacles like men walking around, it will stop and then continue the process. Very interesting and very amusing also to watch for anybody who's a tech enthusiast. Dijkstra, shortest path computation. If you have a lot of stacks, lot of racks, and you want to know the shortest path from a per movement perspective, it is just another algorithm which runs, and the shortest paths can be obtained. RPT, rapidly exploring random trees. It is one of those random series algorithms which only talk about an exploratory kind of a outlook. So with this algorithm fitted, you can have robots or AMRs get into dark places. It can be exploratory, not in terms of supply chain, but in terms of inventory. You want to invent an ancient temple, and you can send these things exploratory in nature. They will go ahead and explore free spaces according to their specification of weight and dimensions. And they also are used in planning. So, for example, there's a lot of warehouse-related planning software which are there. For that, what happens is I've seen this and I've designed software. Initially, what used to happen was men used to go measure it and plan it. So we have RRT enabled algorithm which can scan the entire area, the carpet area or the layout area which is available, slice it and dice it, and with more information on it, it can actually suggest the quickest paths, and also along with the other algorithms which are there. And it can suggest, and it can help in plant planning and resource planning. It can help in the actual layout planning. These can be optimized by softwares like E2Open or inventory management softwares like JDA, which again get this information through sensors, and they kind of optimize it, and you can have the best way your warehouse or inventory storage capacity is handled. Ant colony, very interesting. So it's a heuristic, which means it's a thinking, or it has actual thinking capabilities inspired by collective behavior of ants. Ants, and the Firefly is also similar heuristic, but it's a meta heuristic wherein if there is a touch, it will sense it. This is based on the Firefly mating behavior. Very interesting, very unique. Any heuristic algorithm has the potential to think and learn. So that means to say, if there is a collision first, it will learn not to collide again, not to collide, and it will take back its motion, and next time it will not do the same thing. So corrective measures, prescriptive, preventive, all of these mechanisms coming in play. Firefly series is something that I've seen work in a Fortune 50 bottling company, wherein the racks, depending on the nature of the product, if it is, let's say, for example, just for comparison's sake, let's assume Fanta or Coke, and if it's a Fanta line, and if it is moving, the Coke line has to stop. And then eventually, when that stops, depending on the production planning, the other line starts, so on and so forth. Very interesting, and these robots actually do it in real time. A quick explanation of what actually happens in a Firefly algorithm. The robot initially starts here, initial position, and the robot's path is here, and if there is a cluster over here, the activation of Firefly algorithm for obstacle avoidance starts. You can activate it here. That means to say that you could have had a different strategy until here, and you can activate it here. And if there is an obstacle or the sensing mechanism, depending on the perimeter or the diameter, the capability of the AMR, this can also be channelized, and it will take a different route. Similarly, there are other algorithms which also prevent you from colliding with similar incoming traffic, and thus if there is a touch, it will again sense it and move in a different way. Okay, so let me quickly jump into the most important slide of the day, which is a case study which I did with Sheffield University, sponsored by Sheffield University. This is a cognitive receiving and dispatch warehouse mechanism. It is completely in use by a couple of very big organizations. What we did was what I was probably doing here was creating the API integrations between various SaaS protocols and SaaS inventory mechanisms. But this is what a cognitive receiving or a dispatch warehouse, a completely unmanned warehouse mechanism will or probably look like. So you have your truck coming in, and there you might have a few resources just to see it. And if you have a automated conveyor belt, your goods are automatically coming in. And with technology, you can use blockchain, various platforms available, Sawtooth, Fabric, Hyperledger, you name it, and Matic. There's so many projects out there, blockchain projects, which are niche and which are developed only for supply chain. So you have the automated receiving, tracking, and PLC of the item which is coming in. This is an AMR, forklift AMR that you're seeing, and then it moves through the conveyor belt, which is again an automated conveyor AMR, and there is an RFID fixture here, and there is an API call, and this is automated. The next part is the most unique part. We'll come to the rest of the processes of these bots in a bit. But what happens here is once it is received, the receipt or it is automatically created here. It can be sent through various API channels, through procurement systems, through inventory systems, to accounts payable systems, and of course other various warehouse management systems for to knowing the load in different warehouses. And you still have the ERP, and if there is an integration that is required, that can be done. And you have your suppliers and counterparties and business users interacting on the POs, invoices, and receipts and credit memos, and all the transactional item which is linked to this particular stock which is coming in. So not only is the stock coming in, it is getting received, and all various other parameters like the transactional activities are also getting assimilated here. And with the software bots that we spoke about, SAP, UiPath, this is completely getting automated. But whereas what I'm talking about, the kind of concept that we're talking about from an AMR perspective is the robots, the real life robots are getting influenced, synthesized, and sending back. And, it is literally a marriage between the hardcore, the hardware robot and the software to do what is required. Once the cognitive receiving is done, we have autonomous robotic conveyors which can scan the material for material movement. GMR creations can be done. And then we have the AMRs themselves. So these have been programmed. They have a path planning program, layout management program, which is running in. They know where to go, what to do, and how to put it. Initially, you might compare this to a fully functional, human-driven, human forklift-driven, human intervention warehouses, which is not the case right now. It's completely automated. Rain or shine, these things will do their job. And then you have from this AMR, those AMRs will send an advance shipment notice or a contract compliance as to if there is a certain payment that is required and that is part of the contract, you can have that authenticated here itself. If the weighment is less than 10 kgs and you require each package of this consignment to be of 10 kgs, and if this is not, that data is recorded, even to the granularity. And once it comes down, the fourth mechanism is what the path planning is. So the grid that you see, depending on the path planning software, the grid is now completely functional. The MRs know where to keep it and where to stack it, how to remove it. They know everything about the security precautions which needs to be taken, how to handle this material. All of this is known. Probably if there was a human and if it was his first day in office, he wouldn't really know all this information. He would probably drop a couple of boxes. But here, these know, they learn from their mistakes and it is already stored. Not only storing, it is also the cognitive dispatch that we spoke about. So when there is a dispatch, then there is an order coming out. Yeah, so the dispatch also moves in a cognitive way. We've seen how a completely unmanned warehouse can function with the intervention of AI-related AI concepts, AI path planning, along with the real-time robots itself. So this is a classic example of how we can minimize and move on. I think that's the end of my time. I'm looking forward to questions. I'm glad to take questions at this point in time, please.
Hi
Yeah,
Rajesh,
sure.
this is Priyadarshini. Uh,
Thank
yeah,
you.
is that this autonomous mobile robots are cost effective than the traditional way of using humans?
I'm not getting into the cost part of it. It might be. It's a very competitive and a use case driven question. So for an organization of certain bandwidth or certain returns, certain level, these might be affordable. And for organizations which are not really on that scale or the use case is not that much pronounced, the cost might be less. I have not done a cost analysis. It's just how you can automate a supply chain warehouse from a supply chain optimization perspective, how you can have a completely humanless, fully functioning warehouse.
Yeah, what would be the limitation of this AMR techniques?
There's a lot of limitations. Power is a limitation. Software backup activities, downtime issues. It's not a human, so it needs power. It's not a person that you can call when you require work. So if there is a downtime, everything is affected. Sometimes also the wear and tear of the parts might have to be repaired, just like any capex equipment that you buy in your manufacturing plant, be it a CNC machine, a 3-axis CNC machine, or 5-axis CNC machine, which requires parts and MRO related activities. These also will require MRO related activities. That's apart from the initial setup cost.
Thank you, Rajesh. Yeah.
Okay, thank you so much for your time. And again, I'd like to thank 1.1 GWS for the opportunity. And looking forward to answering your questions. You can connect with me on LinkedIn. If there's any more questions or how we can brainstorm, we can do that. Thank you so much. Have a great
Thank you,
day.
Rajesh.